Hello, everyone. This video is associated with my article published in the Journal of Marital and Family Therapy, investigating the common fate models and numerous derivatives. So this demonstration video will be going over the dual level or the multi-level common fate model. So if you haven't already watched the common fate model video, that may be helpful before diving into this one. So what this video will be going over is the dual level or the multi-level common fate model, which is where we are simultaneously estimating both dyad level effects as well as individual level effects or extra dyadic effects. All right, and so this is the diagram that we will be modeling in M+. So what we have here is we have an independent variable, and we have a right here, and we have a dependent variable here, as you would in the common fate model. And then we have each partner's report on that. So here you have the partner one and partner two. And then you have the same thing for the dependent variable, y1 and y2. So all of this in here is identical to the common fate model. But what we're going to do here in the multi-level common fate model is we're also going to model individual level parameters. So essentially what we're going to look at is we're going to assess, the relationship between, partner one's reports on relationship mindfulness. That's going to be our independent variable, and relationship quality that is unique to them and is unshared with their partner. Right. So what is happening in the common phase? We're capturing all the shared variance between dyad member one and two with this latent variable. But what we can think about theoretically is that, my reports and my partner's reports on how mindful we are in our relationship together aren't going to be perfectly aligned. There's going to be some differences there, right? And so the multi-level common fate model is going to be a way of modeling those differences. So what we're actually going to be able to do is we're going to look at my unique perceptions of relationship mindfulness. How does that influence my unique perceptions of relationship quality that is unshared with my partner? All right. And so we're also going to do the same thing with our partners. So you can kind of think about these as like actor effects from the actor-partner interdependence model. It's my independent variable predicting my outcome. But what we're doing here that's different, the APIM, is we're disaggregating and we're pulling apart what is the shared component, that shared variance. And we're doing that in the common fate space using these latent variables. All right. Because what we can traditionally think about like residuals is that they contain, unexplained variance, measurement error, sampling variability, and all these other explanations around unexplained variance. And we often don't think about those residuals as having a lot of really important information. Well, in dyadic analyses, they're actually really important because, again, that's where the unshared perceptions of relationship mindfulness are going to lie for each person. So, in addition to those typical things that we think about that are located in the residuals, we also have those unshared perceptions in the common fate model. And that's actually what we're going to be modeling here. Right. So what we're going to do is we're going to use what's called phantom variables. Right. So these are our p variables here. And so essentially what we're going to do is we're going to trick our model into, and we're going to create, kind of shift these residuals, what are traditionally called residuals, into actual predictors. All right. And we do that through the use of phantom variables. And so by doing this, we're going to be able to estimate the effect of, again, my level of relationship mindfulness that is unshared with my levels of relationship qualities that is unshared. And that's that gamma 3. All right. And that is not going to affect gamma 1 in any way. All right. So this will not change. This estimate right here will not affect gamma 1 in any way. So essentially, another way to think about this is we are transforming the covariances that we saw in the baseline common fate model into regression coefficients. All right, because now we can account for variance in the dependent variable or in the um, the individual perceptions of each partner on the dependent variable, right? And so that's what we're going to be doing. And now we're going to go over to M plus, and I will show you how to do that. So here in M plus, we are again using the same data file as all as the other demonstrations, right? So I'm not going to go into like the naming conventions and things like that. Those are talked about in a previous video. But I am going to do is I'm going to scroll down to the use variables. So we are going to use relationship satisfaction for men and for women. So this is men, and then this is women. Then we are going to go down to the analysis command, and this is where we are going to use a command that we haven't used before. And so that's going to be the model equals no cove. So essentially what this command in M plus is doing is it's telling M plus estimate the means and the variances of all the variables in the model, but don't correlate automatically the variables together. Because what M plus does by default is all your exogenous variables, all your independent variables that are on the left-hand most side of your model or of your diagram, those are going to be automatically correlated with one another. But we actually don't want that to happen here because what we're going to be doing with the phantom variables is we don't want those correlations to occur, right? So I'll go back over to the diagram and explain a little bit why. And so typically in all regression in all SEM, we have all of our independent variables. Well, they're going to correlate with one another automatically. Every program kind of does this by default, right? And so P1 and P2 actually we're going to make them independent variables. And so what M plus is actually going to do is it's actually going to think that we want this orange covariance here to be estimated. Well, we actually don't want this covariance, right? And so one of the reasons is that we would actually expect this covariance to be zero. So why would we expect this covariance to be zero? Because we are already capturing all of the shared information in the common fate latent variable, right? And so if we remember and recall what P1 and P2 represent, it's my individual perceptions that are unshared with my partner. And so why would that be correlated with my partner's unshared perceptions of the relationship or of their evaluations of me, right? And so essentially we are suppressing this default in M plus. So M plus and correlates this orange line automatically. We are telling it don't do that because we don't want that there, and that can actually create some model identification problems, and your model likely won't even run. You won't get a converged solution. So that is why we have the model equals no cove in the M plus command. So whenever you're using phantom variables, it's going to be commonplace to use model equals no cove. You could also call say model equals no covariances. Same thing. No cove is just a shorthand. Right? And so what we're going to do is we're going to create our common fate latent variables like we normally would. Right? So we have our common fate latent variable for relationship quality, and we have it for relationship mindfulness, and then we have our regression coefficient between the two, where relationship mindfulness is predicting variance in relationship quality. Right? So what we're going to do is we're going to create these phantom variables, which essentially are kind of meaningless variables that we are implementing into the model so that we can get different parameters than we would have that would have otherwise been not possible. So again, we're just tricking the software into allowing us to estimate those individual level regressions. So what we're going to do is that we're going to create this phantom variable. All right. So that's WCSIF. So the naming convention I have here is within for phantom. CSI is the variable, and F is for female. And then we have the by statement. And then we have the female's report of relationship quality, and we're fixing that to be one. So we're fixing that factor loading to be one. So essentially, 1 unit increase in this within variable is going to theoretically cause a 1 unit increase in CSI. So they're going to be perfectly correlated which essentially means that we're not really changing the parameters, right? So remember that I said that what we're doing here is actually not going to mess with the regression coefficients at the dyad level. Well, that's why. It's because we have these fixed to one, right? And so it's also this is also done for identification purposes, all right? And so we create the four phantom variables for each observed variable in our model, right? So we have within for females for relationship quality, within for males for relationship quality, within for females for relationship mindfulness, and within for males for relationship mindfulness, right? And so now these are, because latent variables, kind of by definition for reflective latent variables, are going to be your independent variable, right? So these are going to be your IV, and then this is going to be your DV, right? So remember, underlying latent constructs that are reflective cause or influence, temporally precede the observed indicators that we have using those by statements, right? And then now we just use regression. All right. So now we're going to use within CSI female being predicted by within relationship mindfulness female, within relationship quality for males being predicted by within relationship mindfulness for males. So back on the diagram, these are gamma 2 and gamma 3. All right. So we'll just say this is the female, so that'll be gamma 2, and then the male will be gamma 3. All right. So the within variables are these P's in the diagram, right? So this would be this right here would be P1, this would be P2, this would be P3, and then this would be P4. Right? And then what we do here is we are going to fix the variances of these observed variables to be zero. So essentially what we're doing is we're saying there's going to be no variation of these observed variables. Instead, we're going to pull all that variance apart, kind of like you do like in a multi-level model. And we're going to either allocate it to what is shared at the dyad level up here, or what is unique to the individual right here. Okay. And so that's essentially what we are doing by fixing these variances to be zero. If we estimated these variances, we would actually have negative degrees of freedom, and our model would not run. Okay, but essentially that's why we have our variances fixed at zero. All right, and then we have all of our typical output, our outliers, things like that. All right, we can actually go ahead and we can run this. All right. So we'll scroll down and we'll look at our model fit, right? So it looks really, really good. All right. So all of our CFI, TLI, RMSEA, SRMR, chi-square, they're all cooperating. And what you'll actually notice is that this will have identical fit to the traditional common fate model. So your fit statistics will actually be identical in these two models. These models are what's considered numerically isomorphic. They cannot be empirically differentiated from one another. Because again, all we're doing is really transitioning and transforming those covariances that occur in the baseline common fate model to be regression coefficients using those phantom variables. So we'll scroll down. All of this will be just our factor loadings and our phantom variables. All right. And then we have our dyad level effect at the common fate level. And then here is our within person effect. So this means that unique perceptions of a female's relationship mindfulness that are unshared with their partner is actually not associated with their own unshared perceptions of relationship quality. We see a 0.096 and their standard error is 0.08 and our p-value is 0.234. Right? For men, it approaches significance, but it is not significant. So that means that the effects here of relationship mindfulness and relationship quality primarily occur at the dyad level, and there's very little information for that little information about relationship mindfulness that predicts relationship quality at the individual level, right? And so that is those are the unstandardized effects. And then we can scroll down here and look at the standardized, right? And you will typically see in the multi-level common fate model, your standard errors at the individual level are going to be higher, right? Because we're asking more and more and more out of our data, we're asking more and more out of our model, and there's just going to be increased in precision because we are doing more. So it is not uncommon here to have semi-decent regression coefficients, but with a actually fairly high standard error, and we don't get significant values. And you'll see here, this one's actually 0.051. When you actually have something that is flirting with zero point zero 0.05, let's say this was 0.049, then what you would actually do is you'd want to actually go up and use the unstandardized p-values, because in the standardization, when you go through to standardize the variables, then you will actually potentially modify this p-value and can actually go down, leading to a type 1 error. So when using p-values, don't use the p-values for the standardized, use them for the raw and the unstandardized. Because again, remember, you're through the standardization process, you're dividing by variances slash standard deviations, depending on how you operationalize it. So that's why you would always use the p-values of the unstandardized, because these will differ slightly, because you're dividing by those standard deviations slash variances. So what we can say here is that a one standard deviation unit increase in relationship mindfulness results in a 0.438 standard deviation unit increase in relationship quality at the dyad level. But at the individual level, a one standard deviation unit increase in relationship mindfulness for women results in a 0.119 standard deviation unit increase in relationship quality for women, but that is not statistically significant. Likewise, a one standard deviation unit increase in men's unique perceptions of relationship mindfulness results in a 0.185 standard deviation unit increase in males' unique perceptions of relationship quality, but that is not significant. Right? So that is the dual level or the multi-level common fate model. Again, it's a lot of the same thing as the common fate model. We're just throwing in some phantom variables to transform those covariances into regression coefficients. And so that we can make some more substantive interpretations and really account for variance in those individual perceptions, which we can actually see down here, right? So we can either do 1 minus these values, or we can just scroll down here. So we see that for females, we account for 1.4% of the variance, and for men, we account for 3.4% of the variance, at the individual level. Right? Hopefully, this video has been helpful in understanding a rarely used extension of the common fate model that can model both dyad level and individual level predictors in the same model.